Picture this. You are standing in Rome, the year is 1506. In front of you is a construction site the size of a small city. Thousands of workers move through clouds of marble dust. Oxen drag stone blocks the size of carriages across muddy ground. Wooden cranes creak under loads that would test a modern machine. And somewhere in the middle of all this chaos, an 83-year-old man named Donato Bramante is trying to build something that no one on earth fully understands yet. Not even him. He wants to raise a dome over the tomb of St. Peter, a dome bigger than anything built in over 1,000 years. A dome that would sit 450 feet above the ground, taller than a 40-story skyscraper, without steel, without concrete, without a single piece of modern engineering equipment. Most of his contemporaries think it cannot be done. And they are almost right. Over the next 120 years, the project will outlive 7 architects, survive financial collapse, endure political catastrophe, and come within inches of structural failure. And yet, what they built is still standing today. Still the largest church in the world. Still the most visited religious site on earth. This is how they did it. Rome, 1506. And already there is a problem. Not just one problem. Several. Stacked on top of each other like the very stones they are trying to lift. The old St. Peter's Basilica, built by the Emperor Constantine in the 4th century, over 1,000 years earlier, is collapsing. Its walls are leaning. Its foundations are crumbling. The most sacred church in Christendom is slowly falling apart, and Pope Julius II has decided that patching it is not enough. He wants to tear it down, all of it, and build something that will define the power of the Catholic Church for the next 1,000 years. The budget he sets aside is staggering, roughly equivalent to several $1 billion in today's money. He raises it in part by selling indulgences, a practice that will soon trigger a German monk named Martin Luther to nail a list of grievances to a church door in Wittenberg. But that is another story. The story here is stone and the men who shaped it. Before a single column goes up, there is a question that sounds almost too basic to ask. Where does the marble come from? The answer is both obvious and astonishing. Much of it comes from the ancient ruins of Rome itself. The Colosseum, the temples of the Forum, the great baths of Caracalla. For centuries, Rome's ancient monuments have been treated as a free quarry. Builders pulled marble blocks from 2,000-year-old structures, loaded them onto ox-drawn carts, and hauled them to the new construction site just a mile away. Hundreds of thousands of tons of material, moved by animals and men over unpaved roads, through a city that was simultaneously ancient and under violent reconstruction. Here is the detail that stops people cold. Some of the marble columns inside St. Peter's Basilica today were originally cut by Roman craftsmen in the 1st or 2nd century AD. They passed through the hands of medieval salvagers, Renaissance builders and Baroque sculptors before ending up where they stand now. They are nearly 2,000 years old, and they are still load-bearing. Now the real problem, the dome. Bramante's original plan calls for a dome modelled on the Pantheon, that ancient Roman masterpiece that had stood for nearly 14 centuries without a crack in its concrete. But Bramante wants to go bigger, higher, more dramatic, and here is what makes this nearly impossible. The Pantheon's dome is supported by walls 20 feet thick. It sits low, wide, self-contained. Its weight pushes straight down. Bramante wants a dome that soars, a dome on a drum, a cylindrical base raised high above the church floor, so that the dome itself crowns the building like a second sky. This means the dome's weight will not push straight down. It will push outward in all directions, with a force that could crack the drum, shatter the piers beneath it, and bring the entire structure down. This is not a theoretical concern. It has happened before. In 1284, the choir vault of Beauvais Cathedral in France, the tallest Gothic vault ever attempted, collapsed. Builders had pushed the mathematics of stone too far, and the stone had answered. Bramante knows this history, every architect of his era knows it, and yet he proceeds. There is a detail here that most people never hear. When Bramante dies in 1514, just 8 years into the project, construction has barely begun. The 4 massive piers that will eventually support the dome are partially built, but already engineers looking at the foundations notice something alarming. The ground underneath is not solid enough. The original site preparation had been rushed. The piers are settling unevenly. If nothing is done, the most important building in Christendom will crack at its base before the dome is even started. For years, the project stalls. Architects argue, popes change, money runs out and is replenished and runs out again. 3 different architects take over after Bramante. Each one modifies the plan. Each one inherits the same impossible problem. And then, in 1547, Pope Paul III makes a decision that changes everything. He appoints Michelangelo. Michelangelo Buonarroti is 72 years old when he takes the job. He has spent the previous decades painting the Sistine Chapel, sculpting the David, and designing the tombs of the Medici. He is the most celebrated artist alive. He is also exhausted, increasingly deaf, and deeply reluctant to take on a project this large at this stage of his life. He agrees to work for free, not out of poverty. Michelangelo is wealthy, but because he sees this as a religious obligation, a final act of devotion. And he accepts on one condition: complete authority over every design decision, with no interference from committees or patrons. Pope Paul agrees. What Michelangelo inherits is a half-built church with incompatible plans, settling foundations, and a dome that exists only on paper. What he does next is one of the most remarkable acts of architectural problem-solving in history. He simplifies. Every previous design had grown more complex, as each new architect tried to outdo the last. Michelangelo strips it back. He reduces the number of structural elements. He thickens the walls where they need thickening. He redesigns the drum, that cylindrical base, to distribute the dome's eventual weight more efficiently. And he proposes something that the engineers of his era consider borderline reckless: a pointed dome, not the low, wide dome of the Pantheon, but a tall, pointed profile like a compressed arch. This shape, he argues, will direct the dome's weight downward more effectively than a hemispherical dome would. The outward thrust, the force that had collapsed Beauvais and threatened every large dome before it, would be partially converted into downward pressure. The math, done with compasses and proportional reasoning rather than calculus, suggested it would work. He would not live to see if he was right. Michelangelo dies in 1564 at the age of 88, with the drum completed and the dome still unbuilt. His wooden model, a detailed, room-sized construction that served as the blueprint, survives and is followed, with modifications, by his successors. The dome is finally completed in 1590 by the architect Giacomo della Porta, who makes the profile slightly more pointed than Michelangelo intended. Whether this was an improvement or a departure from the master's vision is still debated by architectural historians. What is not debated is the result. Now think about what it actually took to build that dome. The dome of St. Peter's spans 138 feet across its interior. It rises 390 feet from the floor of the Basilica to the top of the lantern above it. It is made of 2 shells, an inner shell and an outer shell, with a gap between them large enough to walk through. That gap contains hidden staircases, maintenance passages, and the structural ribs that hold the whole system together. The weight of the completed dome and its lantern is estimated at around 14,000 tons. To build it, workers had to lift every single one of those tons by hand. There were no elevators, no hydraulic cranes. The primary lifting mechanism was the same technology used at Notre Dame 3 centuries earlier, the treadwheel crane, driven by the body weight of men walking inside a giant wooden wheel. Updated, refined, made larger, but operating on the same basic principle. Contemporary accounts describe teams of oxen turning capstans to wind cables, chains of men passing buckets of mortar up through the scaffolding, specialised workers called scalpellini, stone cutters, who spent their entire careers learning a single set of cuts, shaping the same profile of stone over and over until their hands could do it without measuring. Here is the human reality behind those numbers. The scaffolding alone required more than 1 million feet of timber. My building it took nearly as long as building some of the walls it supported. Workers climbed and descended those scaffolds every day, carrying loads in heat and cold, at heights that would require safety harnesses and OSHA inspections today. Accidents happened. They are mentioned in passing in the construction records, with the same matter-of-fact tone used to record the delivery of marble. These men were not celebrated. They are not remembered by name. They built one of the most recognizable structures in human history and went home to their neighborhoods in Trastevere and Borgo, ate their meals, and came back the next morning. But there is a crisis in this story that almost ended everything. And it is one that most visitors walking through St. Peter's today have no idea happened. How in the 1740s, nearly 150 years after the dome was completed, engineers examining the structure noticed something deeply alarming. Cracks running through the dome's inner shell, visible even from the floor of the basilica below, not hairline fractures. Real cracks, in a pattern that experienced builders recognized immediately. The dome was spreading. The outward thrust that Michelangelo had tried to control with his pointed profile was slowly, incrementally winning. The iron chains embedded in the base of the dome to contain this thrust, Michelangelo's solution to the same problem that had always plagued large domes, had stretched, not broken, but stretched enough that the dome's base had widened measurably since completion. Pope Benedict XIV appointed 3 mathematicians to study the problem, and they produced what is now considered one of the first applications of structural engineering science to an existing building, a systematic analysis of the forces at work and a calculated prescription for repair. Their solution: add more chains. 5 additional iron rings were embedded around the base of the dome, compressing it back toward its original dimensions. The cracks stabilized, the spreading stopped. The dome has been monitored continuously ever since. It is still being watched today, and the cracks, never fully eliminated, remain visible if you know where to look. This is not a flaw. It is evidence of something more interesting. The dome of St. Peter's is not a static object. It is a structure in equilibrium, a constant negotiation between the weight of 14,000 tons of stone and the tensile resistance of iron rings put in place by engineers who had no computers, no strain gauges, and no structural analysis software. They figured it out with mathematics and observation, and it has held for 4.5 centuries. There is one more thing worth knowing about St. Peter's, something that connects everything we have talked about, the stone, the dome, the crises, the generations of builders, to a single human truth. The construction of St. Peter's Basilica took 120 years. Pope Julius II, who ordered it built, died in 1513. He never saw the walls rise above the foundations. Bramante, who designed it, died in 1514. Raphael, who briefly took over, died in 1520 at the age of 37. Michelangelo died in 1564 with the dome unfinished. Giacomo della Porta, who completed the dome, died in 1602 before the interior was finished. The basilica was finally consecrated in 1626, 120 years after the first stone was laid. No one who started this project lived to see it finished. Think about what that means for a moment. Every person who ever worked on St. Peter's, every architect who agonized over the dome's profile, every scalpellino who spent 30 years cutting the same curve in marble, every foreman who organized the scaffolding at dawn. Every one of them did their work knowing they would not see the result. They built it anyway, not because they expected to be remembered. Most of them are not. Not because they would benefit from the finished building. Most of them worshipped in small neighborhood churches. Not in this monument to papal power. They built it because the project was larger than any individual life. Because some things are worth doing even when you cannot see the end from where you are standing. That idea, building for a future you will not live to see, is not unique to St. Peter's. You find it at Notre Dame, at Chartres, at every great medieval and Renaissance cathedral in Europe. But nowhere is the gap between the lives of the builders and the life of the building more stark than here. 120 years, dozens of architects, thousands of anonymous workers, one building. Today, approximately 10,000 people enter St. Peter's Basilica every single day. They walk across the same floors that took a century to lay. They look up at the dome that nearly spread itself apart and was saved by iron rings and mathematics. And they stand in a space so large that the mind has genuine difficulty processing its scale. The baldachin alone, the bronze canopy over the altar, stands 98 feet tall. That is roughly the height of the Statue of Liberty from base to torch. Most visitors spend an hour or two inside and then move on. What they are standing in, what they are briefly inhabiting, is the accumulated labour of over a century of human effort. Stone quarried from ancient ruins. Marble carved by men whose names appear nowhere. A dome that almost failed and was saved by chains. A building that outlived every person who built it, and will almost certainly outlive everyone who visits it today. There is a word for what you feel when you stand in a space like that. It is not exactly awe, though awe is part of it. It is not exactly humility, though that is there too. And it is something closer to perspective, the recognition that human beings, at their most determined, are capable of things that extend far beyond any single lifetime, that the right kind of ambition, patient, collaborative, willing to correct its own mistakes, can produce results that no individual genius could have managed alone. St. Peter's Basilica is not the work of Michelangelo, or Bramante, or any of the other famous names attached to it. It is the work of time, and of the ordinary men who gave their time to it, one stone at a time, for 120 years. They did not build it for themselves, they built it for us, and against every reasonable expectation, here we are.